So when I ask you to tell whether an ordered pair is a solution, we're going to do the same thing. We're going to plug in x and y into our inequality and then decide, does it work or does it not? So I'm going to plug in 0, 0 in for x and y and see what we get. So if I plug in 0 for x and 0 for y, simplify, we end up getting what? Negative 0 is just 0. Anything times 0 is 0. So you have to ask yourself, self, is 0 less than 8? So then yes, it is a solution. Okay. Try one more time. Minus 0 plus 2 times 4 is less than 8. 0 plus 8 less than 8 is 8 less than 8. No. No, it's not a solution.
Yeah, really.
Okay.
No. I also want to know. No. Negative 0 is.
So, no. So, no, not a solution. Okay. Minus 3 plus 2 times 5 less than 8 is negative 3 plus 10 less than 8. We'll go double exclamation point. So yes. And underline. Yes, this is a solution. 3, 5 is a solution of this. Okay. When we're graphing inequalities with two variables, we're going to be basically drawing lines. We're going to take lines, we're going to throw in some like 4th grade coloring skills, and voila, you're going to get yourself the equation, the solution to a two-variable inequality. Okay. We're going to do this in 3 steps. Step 1, we're going to rewrite. We're going to do this in 3 steps. First, we're going to rewrite the inequality in mx plus b, or what's called slope-intercept form. Okay. Notice we're going to be using inequalities, so this will be like a greater than or maybe a less than symbol. It won't be an equal sign, but it's the same idea. Rewrite it so it's in y equals mx plus b form, essentially. Okay.
What's that word next to slope?
Intercept. Step 2 is pretty much the same as we did before. Then we're going to graph. Graph the line as though there is an equal sign. So up to this point, we've done nothing different. We're going to write it in slope-intercept form. We're going to graph the line just like we would have if there's an equal sign. So find the y-intercept, use the slope to find a second point, draw a line. The only difference is we're going to start changing things just a little bit at this point. If it's greater than or less than, then we'll use the dotted line.
That is the fish.
We're going to graph just like an equal sign. Only thing, there's one thing we're going to look out. If you would have on your number line had an open circle, then we're going to kind of translate that into a dotted line when we graph. So your line will be like a dashed line. That's the same if whenever you would have had an open circle on a number line, then you'll have a dotted line when we graph our lines. Anytime you would have had a solid filled-in bubble, then we'll have a solid filled-in line when you're graphing. Okay, just kind of to represent the same thing. If it can't possibly be equal to something on that line, then we'll have a dashed line to represent. If it can be, then if you would have used, say, a fill-in bubble on your number line, then we'll use a solid line when we graph it. So steps 1 and 2 are basically just graphing lines that we've seen done in the past. The last part is kind of where it separates this into being an inequality. And that an inequality doesn't, their solutions don't necessarily have to be right on the line. They can actually, they'll always fall on what's called one of the half planes, which are making like half of the side of the graph paper. So to figure out what side that is, we're going to end up doing some coloring here. We're going to shade a side of the line.
Oh, I remember.
Yep. You should have done this a little bit in 8th grade.
Oh my gosh, I love this.
We're going to shade the correct side of the line. So there are a couple ways to figure out what the correct way is. This is the way I think is the best. And this is called, we're going to pick a test point. A test point being a point not on the line. Does anyone want to take a stab in the dark at what the best possible test point is if you have one? What's the best possible test point? If at all possible, choose 0, 0, if you can. Okay, preferably 0, 0. The reason we're going to do this is because if you're in slope-intercept form, there's going to be a lot of times when that x is going to be multiplied by a fraction. Well, what's anything times 0? 0. So if we pick x to be 0, then we're going to multiply whatever that crazy fraction is by 0, just kind of eliminating that fraction for the slope. So this should make life easy for us. Okay. So once we pick the test point, we're going to plug it in. So we'll plug in. Sure. We're going to plug it in and see if it is a solution. If it is, then shade the same side of the line as the test point. If no, shade the other side of the line. Okay, so we have 5 examples on the back side. I'm going to get through at least 4 of them. Okay. We'll start with the first one. Notice that this is already in slope-intercept form. This is y is greater than or equal to mx plus b. So there's not really any of that preliminary work we need to do. We don't need to rewrite this thing. It's already in the form we want. Y mx plus b. Okay. So now that's there, let's graph it. So the slope and the y-intercept. Slope is 3. It's multiplied to x, or maybe better as a fraction, 3 over 1. The y-intercept is added on to this, which is 1. So let's graph this. Y-intercept of 1 goes right here. Slope tells me how to get to a second point, so I'll go rise over run, 3 over 1. And then I need to connect these points, excuse me. Are they going to be, am I connecting them with a addition sign or with a, with a dotted line or a solid line? Solid line. It's or equal, so I would have had a solid dot, so I'll graph with a solid line.
See, if there's a solid line on the alligator, you graph with a solid line.
Sure.
But if there's no solid line on it, it's there.
Very good. That makes sense.
That's good. So I'm not done yet because it's an inequality. So now I need to figure out what side to color, what side to shade to represent where all the solutions are. So I'm going to pick a point that's not on this line. Is there a good point that's not on this line?
0, 0.
Yeah, this one right here. You don't have to label it, but I will for the notes, just so we know that I'm picking this as a test point. 0, 0.
It does not work.
So I'm going to plug in. Here's my test point. So I'm going to put, if this is my x and y, I'll go 0 is bigger than 3 times 0 plus 1. Is 0 bigger than or equal to 1? So this test point is not a solution. So then where are the solutions if that's not one?
On the other side.
On the other side of the line. So the solutions are everything on the other side of the line. Let's look at this second one. So we have x plus 4y is less than negative 8. What do we need to do this first before we start trying to graph it? Let's get mx plus b form here. So let's subtract x from both sides. We get 4y is less than minus x minus 8. You divide everything by 4, and welcome to fractions, because here's another one. Here's one for you. Okay, 8 over 4 is an easy one. That's 2. But problem here is minus x over 4. We'd like to have that as a fraction times x. Boy, how are we going to write minus x over 4 as a number times x? So we figure out what the slope is.
0.25.
Okay, we don't want decimals. That doesn't help us with slope very much. But we could put this missing 1 that's in front of the x here. So then what fraction did we just form? Negative 1 over 4 times x. Okay, so then what's the slope of this line? Negative 1 over 4, what's the y-intercept? Right here, it's b. So when we graph this, we'll find the y-intercept, negative 2. The slope is, we left it purposefully as a fraction because this tells us rise over run. This tells us to get to another point. So negative 1 over 4 tells us to go up negative 4 and to the right positive 4. Sorry, up negative 1 to the right 4. Or up negative 1, same as going down 1 and to the right 4. Conversely, you could have went up 1 and to the left 4. Gives you points on the same line. Is this a dotted or a solid line? Dotted. Okay. This would have been an open circle if we were graphing this on a number line. But instead of an open circle, we'll represent that with a dashed line and not solid line. Okay. Next, let's say I got to pick a side to shade. So I got to figure out what the right side is. So let's pick a test point. Pick a point that's not on this line. What's a great point that's not on this line? Yeah, this one right here will help. Should be easy for us. So let's test 0, 0. So I'll plug in 0, 0 into the equation I just wrote. And I'll get 0 is less than negative 1/4 times 0 minus 2. As I said, it's great when x is 0 because 0 times whatever this fraction slope is just 0 itself. So when we simplify that, you get is 0 less than negative 2? So then the test point is not a solution because 0 is not less than negative 2. So this is not a solution, so where am I shading? I'm shading wherever the test point is not. So I'll shade below this line. You don't have to. It doesn't need to be another color. I just had a colored pencil, so you gotta do a different color. Okay. I'm gonna leave this one for you to do on your own. Let's look at the 2 below. Oh boy, there's only one variable in here. Okay, what do y equals equations look like? These go way back. Dig deep. Brendan, what do they look like?
Up and down.
You go like vertically.
Okay, so we're kind of in the right area there. We have either only y's or only x's. One of them is going to be a vertical line. One's a horizontal line.
X is a vertical.
You could prove to yourself which is which. If I made a table of values of y, but y equals 1. If you did x and y is always 1, no matter what x you pick. So these points would be at, say, when y is 1, x is 0, x is negative 2, y is 1, when x is 1, y is 1, when x is 3, y is 1, when x is negative 1, y is 1. What kind of line is that forming? Y equals our horizontal lines. So this inequality should be a horizontal line through y is 1. Is this a dotted or a solid line?
It would be dotted.
It's most certainly a dotted line. Okay, it's an inequality, so I better shade this somehow. How am I going to figure out what side to shade? Let's pick a test point, Jacob. That's a great idea. What point should we pick?
0, 0.
Boy, that's a great suggestion. Let's test 0, 0. Oh, there's no x's to even bother plugging into here. So I don't have to even worry about it. So we're going to say, is 0 less than 1? Yes. So I'm going to shade the same side as the test point, since this is a solution. So below this line. Even actually goes down. Okay. So then if y equals is a horizontal, what's an x equal line?
Vertical. I'll like that first.
Vertebrae.
So vertical line through 2. So x is 2 is over here. And it's a vertical line. Is it dotted or solid? Solid line. Oh, how about we pick this test point here? Is 0 bigger than or equal to 2? So then our solutions are this is not a solution, then our solutions are on the other side. There you have it. If you can graph lines and if you can find solutions and maybe throw in some coloring skills like staying inside the lines, then you can do section 6.7.